This lesson is for Chapter 4, Section 2, Graphs of Rational Functions. So open up your books and your notes and we'll get this one going. So there's a number of steps that we can consider to help us make the graphing of these rational functions a bit easier. If you look on page 320 in your textbooks, you can see this this slide is the summary of that table that's on there. Step number 1 says simplify the parts of the functions if you can. So a lot of times with your rational functions, you might have a polynomial on the top and a polynomial on the bottom that could be maybe factored, and then things might cancel out, like a common factor would eliminate. So look for that first. See if you can reduce or simplify the function before you even begin the rest of this step. Number 2, find the y-intercept and plot it. Okay, plug 0 in for x. Most of us all do that anyway, because when we're building like a table of values, generally the easiest one to plug in is a value of 0 for x. But make sure that you do get that one value in your table. Find the zeros of the numerator. These are going to be your x-intercepts. Okay, so remember when the numerator is 0, the function's value is 0. And those are going to be our x-intercepts on our graph or on our picture. Find the zeros of the denominator. Okay, remember zeros in the denominator of anything are undefined. They will be our vertical asymptote still. We talked about that in section 1. Find and sketch the horizontal asymptote if it exists. Okay, so give yourself that horizontal line also that your graph is not going to reach. If you don't remember whether or not a function is going to have a horizontal asymptote, look back on that page 314 and it gives you those 3 situations to consider. Number 6, plot at least one point inside and outside of each of those intercepts and asymptotes, just to give you a better idea of what your curve is going to fill in and look like. And then just connect it all with some smooth curves. All right, so if we were going to sketch the graph of this function, a table of values is going to come in handy, but first we are going to check and see if we have any asymptotes in this thing. The domain on this one, you know, if you're looking at your denominator, we have an x equals 2 as our denominator. So we can use everything in our domain except x cannot end up equaling a 2. Okay, so we have a vertical asymptote. I'm going to abbreviate here, of x equals 2. So that vertical line will never be reached or touched or crossed. Horizontal asymptote. Okay, looking at this one, notice that the degree of your top function is 0 and the degree of your bottom function or denominator is 1. So since the numerator has a smaller degree than the denominator, our horizontal asymptote is automatically y equals 0 or the x-axis. Okay, so a vertical asymptote of x equals 2 means that we're not going to cross or hit that line. And then the x-axis is our other one. So again, we'll move closer and closer to this line, but we're not going to cross it or hit it. The rest I'm just going to generate with a table of values. Now generally I pick a lot of them. So I want to come into my vertical asymptote of 2 from the left, and I also want to come into it closer and closer from the right. So I pick lots of values. I always pick 0, okay? I picked a 1, and then I moved closer and closer and closer with some decimals. All right? Then, just on the other side of x equals 2, I started picking some numbers 2 and moving away from it to the right, just so I would get a nice general tendency or an idea of what this curve is going to do. All right, so filling in the values I found when I plugged these into my function 3 over x minus 2, I got, and you would also, these values. But for the sake of time, I'm just going to pop them right down on paper. Whoops, hold on. 2.1 was 30, 2.5 was 6, 2.8 is 3.75, and 3 and 6 have 3 and 1. All right, so now you just start plotting. So at 0, we're at a negative 1.5. At 1, we're at a negative 3. 1.3, we're just going to keep going down and down and down and down. Okay, so you can kind of see what it's going to do. It's never going to hit the axis, the x-axis, and it's never going to hit that y equals 2 line. So it's going to do that on that side. And then plotting our points on the other side. 2.1 and 30 I can't even get on my graph. So 2.5 is right about there at 6. Oops, that didn't go where I wanted it to, but we'll get the gist. 2.8 was 3.5. So lower. 3 was 3. 6 was 1. And you can see how it's going to curve around here and flatten out too. And there's the sketch of our graph. Okay, let's do it again. All right, so we're going to go through the same kind of process. First, look and see if you can reduce. There's nothing that I can factor out of any of these parts. There's no numbers that I can cancel, so I keep everything that I have and I start to look for my asymptotes. I will be finding my intercepts. I just do that in a little bit here. So my domain again, I'm looking at that denominator of 1 plus x. Again, I'm going to be able to use all reals except this time x cannot equal a negative 1. So my vertical asymptote is going to be x equals negative 1. Not going to cross that line or hit it. Horizontal. Okay, horizontal asymptote. This time, do you see how the top function, your numerator function, has a degree of 1, and the denominator function has a degree of 1 as well? Remember back to page 314, if the degrees match, your horizontal asymptote is going to be the line at y equals a over b, or the degree or the lead coefficient of the top function, which in this case is a 2, over the lead coefficient of the denominator function, which in this case is a 1. So we end up with a horizontal asymptote of y equals 2. Okay, so quick sketch. X equals negative 1 is this line. I'm going to quick align my pens again because this is driving me crazy. Hold on, sorry. There, we'll see if I can't get them to hit where I want them a little bit better now. So x equals negative 1. That's better. There's a vertical asymptote. My horizontal asymptote was y equals 2. Okay. Now again, I just built my table of points, making sure that I did include x equals 0 as one of them. So again, I chose a ton. Here's all the ones I chose coming in from the left. And going back away on the right. Okay, so right here, of course, is right about where that break with my asymptote happens, when I transition from the left side of negative 1 over to the right side of negative 1. All right, so again, all I did was plug these x's into my function. This is what I came up with. So coming over here now, transferring in my points and graphing. Negative 3 was at 1.5. Negative 2 was at 1. Negative 1.3 was at negative 1.3. Negative 1.1 was at negative 8. See how it's going to drop here? Okay, so you can see that outline of that curve. Those points we're going to be able to connect with a smooth curve, and it's going to do this. Okay, then negative 0.9 and 12. So just on the other side, we're way up high. And then coming down, and at 0, we have our intercept 0, 3, and 1 has 2.5. So you can see here too that it's going to come down and it's going to graze that other asymptote right there. Okay? All right, moving on. Another one. Okay, again, look at this. It's getting bigger. Okay, so the numerators and denominators are getting a little bit more involved. But looking at this one, there still isn't any way that we can factor and reduce or cancel. But when we are considering our domain, we have a polynomial in that denominator. We're going to have to factor that and figure out all of our zeros. So my domain is going to factor into an x plus 2 and an x minus 1. So we have 2 points, or 2 numbers at which our denominator is going to end up being a 0. We have negative 2 and we have positive 1. So our domain is all reals except x cannot equal negative 2 and x cannot equal 1. So you have 2 vertical asymptotes. You have the x equals negative 2 line, and you also have the x equals 1 line. Okay, for horizontal. Okay, take a look at your degrees. Okay, we have a numerator with a degree of 1. We have a denominator with a degree of 2. Since the numerator degree is smaller than the denominator, we once again have that y equals 0 as our horizontal asymptote. Again, that's back on page 314 if you forgot those 3 scenarios. All right, so very quickly, let's give ourselves a bit of a picture here. This one's a little bit more complicated because we have an extra vertical asymptote. So, negative 2 is 1. X equals 1 is another. So we've got a couple of breaks as we go from left to right. And we also have, whoops, my pens aren't that far off already. Ah, hang on. I don't know what does that. Graphing's really hard when I can't hit where I'm trying to hit. Oh, that's a little better. Okay, so here's your horizontal asymptote that you're not going to cross either. Okay, so my table of values. Okay, you want to make sure that you go inside, outside, left, and right from both of those vertical asymptotes. So I need to pick a bunch out here. I need to make sure I pick a few from inside or in between them, and then also out here. So I have kind of 3 different sectors that I want to be testing. So here are the ones that I chose this time. I went with a negative 4 and a negative 2.5, and a negative 1.5, a negative 1. Here's my 0. And then I went with 0.5, 1.1, 2, 4, and 8. You can pick many more. You can pick ones other than the ones that I did. Okay, but I'm trying just to get a picture of where this graph is going to go. So negative 1.2, negative 4.3, 3.6, negative 1 went with 1.5, 0 was 0, 0.5 was negative 1.2, 1.1 is 10.6, 1.5, 4 was 0.7, and 8.3. All right, so let's start plotting these points that we came up with. Negative 4 and negative 1.2-ish, somewhere around here. Negative 2.5 and negative 4.3. So at 2.5, we're down here. So you can already kind of get an idea of where that one's going to go. It's going to hug along that asymptote and then come and drop down next to that one. Okay, so negative 1.5 is inside, and it goes up here to the 3.6. Negative 1 is 1.5, 0, 0. And then 0.5 is negative 1.2. And that one gives me, kind of does this curly Q, oops, I missed, curly Q thing through the center. All right. Then we have a few more points to go here yet. We have 1.1 at 10.6, so that's way up high. So coming in up here. 2 is 1.5. 4 is 0.7. 8.3, so I think you can kind of see that it's going to flatten out there. So it's going to come in steep and hug that asymptote again. Okay, one more. This one's yet a bigger rational function. Now I think most of you are going to notice on this one that the numerator and the denominator can both be factored, so there's probably a pretty good chance that we're going to be able to cancel something out this time. So factor the top. Okay, so like step 1 on that big chart said, simplify if you can first before you begin all that other stuff. Notice in the numerator and denominator we both have a factor of x plus 2, so we're going to reduce them out. So we're reducing our function and coming up with x minus 2 over x minus 3. Now we're going to go ahead and do our process with this reduced version of our function. Okay, so now the rest of it is the same. Our domain, all reals, except x can't be 3. So our vertical asymptote is x equals 3. Horizontal. Both of these had degree of 2, or in our reduced form, degree of 1. So either way, you're going to take that lead coefficient. So y is equal to 1 over 1, or we have a horizontal asymptote of y equals 1. Okay. Then again, we're going to go ahead and generate that table of values from this. Okay. Go ahead and sketch my asymptote over here. So I'm going to pick values to the left and to the right. And I have a vertical or a horizontal one of y equals 1. So we're going to throw that down there. So if I want to pick values coming in toward the 3, just give yourself 0, 1, maybe 2 and 2.5. And then on the other side, let's go with 3.5, 4, and 5. That'll be good enough. Okay, so we put a 0 in. We're going to get 2/3. A 1 in gives us a, negative 1 over negative 2. 2 in gives us a 0. 2.5 gives us a 1. I didn't do this one ahead of time. I probably should have. So 2.5, I'm going to do my work off to the side here. And then 2.5 minus 3. Oh, it's going to be a negative 1. So 2.5 minus 2 is 0.5. 2.5 minus 3 is negative 0.5. We're going to get negative 1 there. 3.5 gives us a 1.5 on the top and a 0.5 on the bottom, so 3. 4 in gives us a 2 on the top and a 1 on the bottom. 5 gives us a 3 on the top and a 2 on the bottom, so 1.5. So let's see what our picture is going to kind of look like. So 0 and 2/3 be under here. 1 and it's coming down a little. 2 and 0. So I think you can kind of tell that we're going to skirt it and hug it and do this. 2.5 was negative 1. Oh yeah, we can see that there. Okay, 3.5, going on the other side of the line now. 3.5, we were at 3. 4 came down to a 2. 5 was 1.5. And again, you can see what this is going to do. It's given us enough to figure out how the curve and the shape is going to go. Okay. Now, there's also something called a slant asymptote. This is going to happen if the degree of the numerator is exactly 1 more than the degree of the denominator. Okay? So if the degree of the numerator is exactly 1 more than the degree of the denominator, there's going to also be a slant asymptote. Okay, so to find the equation of this, we're going to use a process of long division. This is actually kind of slick. Use long division to divide the two functions together. So a numerator over denominator says the numerator is divided by the denominator. I think you guys remember that from the days of fractions. Top divided by bottom. Now when you do that division, the quotient or the answer that you get is going to result in a whole part and then a remainder. Well, it's this part that's not the remainder that becomes the right-hand side of an equation of the slant. So do you see over here, this would be the equation of that slant asymptote. So the quotient part, not the remainder, is like the mx plus b part of a line that you would graph. Okay, so that's going to give you that slant line or asymptote that's going to be in your graph. Another point or a line that our graph isn't going to touch. Let me see if I can move this out of our way. So looking at this one then, notice that the top or the numerator function has degree of 2 and the bottom has degree of just x or 1. This is one that we're going to be able to use this process. We know we're going to need to come up with a slant asymptote. So using our division, 3x squared plus 1 divided by x. Okay, so we get 3x and we get a 1. Okay, so disregarding the remainder part, 3x is the regular quotient part. So I have a slant asymptote of y equals 3x or 3x plus 0 if you want to have the y equals mx plus b. Okay, so a slant asymptote. Now you can still go and do the other ones. With this one you have 0 as an undefined value, so our domain is everything except x equals 0. So we have a vertical asymptote at x equals 0, it's the y-axis. The other one, the horizontal asymptote, notice that your numerator is bigger than your denominator, so it's not going to have one. Okay, when the numerator is bigger than the denominator degree, there will be no horizontal asymptote. Again, that's back on page 314. That's what part C on that horizontal asymptote finding told us. Okay, so if we know these things, let's graph our asymptotes in there. So x equals 0. Okay, we're not going to hit that. And then we also have y equals 3x. So if we graph y equals 3x, we also have, give us a couple points going this way too. This line is an asymptote. All right, so let's come up with some values here as well. Okay, so we want to come into x equals 0 from the left. So maybe -3, -2, -1. And then we have to go away from it on the right as well. So let's see what whole numbers don't give us. All right, so -3 going in gives us a 28 over -3, which is roughly -9 1/3. A -2 goes in, what, 13 over -2, which is a -6 1/2. -1 in there is 4 over -1, or -4. +1 in there, we have 4 over 1, which is 4. A 2 going in there is going to be 13 over 2, or a +6.5. And 3 going in is going to give us a 27 over 3, or a +9 1/3. Okay, so let's graph these initial points and see if that's enough. So -3 and -9 1/3. Whoop, a little lower than I meant. -2 and -6.5. -1, -4. Okay, then +1, +4, 2 and 6.5, 3 and 9 1/3. Okay, so if I got closer, okay, we'd probably on this one have to do like a -0.5, -0.7. We can't cross that axis, so it's going to come up high and then it's going to squirt around and go back down. Same thing's going to be true of this. We can see that we're going to do this along that slant asymptote. If we would pick 0.5s, 0.3s, things like that, we're going to see that it's going to shoot back up. Okay. All right, so our assignment, 325 to 327. You're going to need a sheet of graph paper. Okay, you're going to be doing some graphing on graph paper. So if you don't have any at home, I attached a sheet to my web page. Go back, pick the college algebra page, and go underneath the calendar. When you click it, if it doesn't kind of show very well, if it looks like a blank sheet of paper, try hitting the download button up top, and hopefully then it'll download it and you'll have it. Otherwise, just go online and find yourself a couple sheets of graph paper. I think I gave you 6 problems, so you'll probably need 6 grids. So if you don't have your own, use one of those options to come up with some graph paper to do this homework.